On October 22, 2006, an 86-car train carrying ethanol derails in rural Pennsylvania, sending some tank cars into a river, while others burst into flame. May 14, 2007, a cargo tank carrying 8,000 gallons of ethanol overturns and bursts into flame on an interstate in Baltimore, Maryland, killing the driver and sending a burning stream of ethanol into the street below. Ethanol can be dangerous, and as production and use become more prevalent, it's vital that firefighters and responders understand what they may be up against.
Ethanol use is expanding, with more than 9 billion gallons produced and blended in 2008. The federal mandate for renewable fuel consumption, including ethanol, calls for 11.1 billion gallons in 2009, 15 billion gallons by 2015, and 36 billion gallons by 2022. With this increase in demand comes a significant and necessary increase in ethanol production. Consequently, the likelihood of an ethanol-blended incident will also continue to rise. Per the U.S. Department of Transportation, there is an average of 99 rollover accidents involving cargo tanks every year. With over 50,000 shipments of motor fuel every day, there is a growing likelihood that ethanol in some form will be involved in these incidents. It is imperative that firefighters understand what ethanol is and the different challenges ethanol and ethanol-blended fuels pose to responders.
Ethanol, or ethyl alcohol, is a high-octane renewable fuel source produced from corn and other natural products. It's most commonly mixed with gasoline in varying amounts for use in commercial and private vehicles. Traditional methods of fighting gasoline fires are not effective at combating fires involving ethanol or ethanol-blended fuels. Due to the different chemical properties and reactions of ethanol, it's essential for responders to be well acquainted with possible ethanol incidents, scenarios, places they may occur, and how best to deal with them. This video will equip you with a basic understanding of how to identify and prepare to combat incidents involving ethanol. You'll also need to research and understand how ethanol is used in your own community and conduct thorough pre-incident planning exercises in order to be adequately prepared. It's paramount that emergency responders become familiar with the use, transport, storage, and extinguishment of ethanol and ethanol-blended fuel fires. Since the late 1970s, ethanol has been used as an octane-enhancing gasoline additive that also helps achieve environmental air quality goals. There are 3 common ethanol blends. The most prevalent today is E10, a 90% gasoline, 10% ethanol blend. This blend may soon be found in every retail gas station across the country. Ethanol, coming straight from a production facility, is referred to as fuel-grade ethanol, ethanol denatured with 2 to 5% unleaded gasoline. This is sometimes referred to as E98, E95, or denatured ethanol, and is the most common blend transported in bulk by truck, tank car, or barge, from production facilities to terminals and other distribution points. Because of taxation requirements from the Bureau of Alcohol, Tobacco, and Firearms, ethanol is rarely shipped in its pure form. Finally, E85, 85% ethanol and 15% gasoline, is now being sold into a developing market as a retail blend for flexible fuel vehicles only. As of 2008, there are close to 2,000 fueling sites handling E85 across the country.
Characteristics of hydrocarbon fuels and the most effective techniques for fighting incidents involving them are well known in the fire protection community. However, as ethanol blends are used more and more, it's important to understand the differences in their chemical properties. Any ethanol fuel blend with approximately 10% or more ethanol will begin to exhibit the characteristic traits of a polar solvent rather than a hydrocarbon such as gasoline. An easily visible difference between the two is that while gasoline will float on top of water, ethanol is water-soluble and freely mixes with water at any concentration. This is an important distinction from traditional gasolines that are 100% hydrocarbon. To the fire responder, this means that the dilution of ethanol when burning is almost impossible, as it takes at least 80% water to dilute ethanol enough to keep it from burning. Responders need to familiarize themselves with the different characteristics of gasoline and various ethanol blends. For example, while gasoline has a flash point of -45 degrees Fahrenheit and a flammability range of 1.4 to 7.6%, fuel-grade ethanol has a flash point of -5 degrees and a flammability range of 3.3 to 19%. Black smoke from burning gasoline can be thick and easy to see. Denatured fuel-grade ethanol and E85, however, produce little to no smoke, but have a visible blue or orange flame. Pure ethanol, also known as neat ethanol, found primarily in processing facilities, is nearly smokeless, but will have a visible flame when burning, whereas E10 will look similar to gasoline when burning. Therefore, the lower the concentration of ethanol, or the more hydrocarbon material that is being consumed in the fire, the more intense the flame and generation of black smoke will be.
Given the increasing likelihood that a fuel transportation-related incident will involve ethanol-blended fuels, it's essential that a first responder be able to quickly and accurately identify the presence of ethanol at the scene of an incident. There are a variety of sources from which emergency responders can glean information about the chemicals involved in spill or fire incidents. Among them are material safety data sheets, MSDS, UN numbers, DOT placards, NFPA 704 placards, shipping papers, and manifests. The most prevalent style of transporting blended fuels that emergency responders will encounter is cargo tanks. Every transporter of hazardous materials carries either shipping papers or a manifest providing information about the products they are transporting. Gasoline and ethanol blended fuels are transported in the same general types of containers and tanks. These cargo tanks can typically carry up to 9,200 gallons of fuel. Ethanol and ethanol fuel blends are flammable liquids. Placards for flammable liquids either have a red background with a white flame, with or without the word flammable in the foreground, or a red background with black flames. Cargo tanks displaying a specific UN number can identify a more specific fuel blend. You can look up this 4-digit number in the Emergency Response Guidebook to find hazard response information about the material. Containers on barges and railroad tank cars will be identified similarly. Tank cars can typically carry up to 30,000 gallons of fuel, while barges can hold between 420,000 and 4.2 million gallons. Most incidents involving hazardous materials tend to occur during transportation and transfer operations. Emergency responders should be aware of areas or routes where large shipments of fuel-grade ethanol and ethanol-blended fuels routinely pass. Fuel-grade ethanol has now become the leading hazardous material transported by rail. It's also transported on our nation's waterways, in barges or cargo ships. A pipeline transfer of fuel-grade ethanol was tested successfully in Florida in October 2008. Depending on regional markets, testing on other pipelines will follow. One way of finding information about hazardous materials transportation in your area is through TransCare.
There are more than 160 ethanol plants in operation in the United States, with dozens more under construction. And responders who don't have a manufacturing site in their jurisdiction still need to be very familiar with ethanol storage. There are hundreds of ethanol terminal storage facilities and smaller bulk distribution storage facilities across the country. The most common storage container for this product is the carbon steel closed roof tank, many with aluminum internal floating roofs. The most common mixture of ethanol-blended fuels stored at terminal facilities is denatured ethanol. Common consumer formulations such as E85 and E10 are generally blended in the correct proportions into the cargo tank during the loading process for transport to distribution facilities or retail outlets. Smaller bulk distribution storage facilities pose another challenge to local fire departments. These facilities are located throughout communities to better distribute fuel to end users. Storage tanks in these facilities can be any age and connected to a variety of process systems. Many bulk storage facilities have built-in fire protection systems, although these can be easily damaged at the onset of a fire incident. All of these facilities are designed with limited fuel spillage containment structures or areas. The majority of retail gas stations have underground storage tanks. These facilities are relatively small in terms of storage volume, ranging from a few thousand gallons up to 20,000 gallons. In most cases, these gas stations are filled by cargo tanks coming directly from terminal facilities. Many of these facilities have multiple loads of fuel that are being delivered daily. Emergency shutoff valves and loading and unloading points will vary at each location due to design and construction differences. Pre-incident planning for potential events at tank farm facilities, distribution centers, and retail outlets is extremely important. Responders need to be very familiar with what is in their jurisdiction and be prepared for all emergencies, namely large-scale emergencies, and be equipped with the most effective techniques and extinguishing products.
As we've already seen, ethanol and ethanol-blended fuels are polar solvents, rendering water an ineffective tool for fighting fires. Polar solvent fuels are destructive to traditional foams designed for hydrocarbons because the alcohol or ethanol content of the blended fuel literally attacks the foam solution, absorbing the foam into the ethanol-blended fuel. The only effective foam for use with a fire or spill involving ethanol or ethanol-blended fuels is alcohol-resistant, referred to as AR foam. A special polymer in the AR foam creates a barrier between the foam and the fuel to form a cohesive floating blanket. The water content of the foam cools the fuel surface, while the blanket keeps flammable vapors from escaping. While many extinguishing agents are effective on flammable liquids, only foam is capable of providing visible proof of security. Creating a foam blanket can keep a spill from catching fire, can prevent reignition by suppressing vapors, and can provide post-fire security by protecting the hazard until it can be secured or removed. Certain applications of foam also have the property of adhering to surfaces, which provides a degree of exposure protection from the radiant heat of adjacent fires. It's crucial that AR foams are used in combating ethanol-blended fuel fires, especially E10 and above. It may not always be easy to identify the various fuel blends involved in an incident. Because AR foam is universally effective on both ethanol-blended fuels and non-ethanol-blended fuels, it should be considered the foam of choice. It's recommended that fire departments stock AR foam concentrates, develop access to a readily available cache of AR foam through regional cooperation, or consider using portable foam delivery systems. In order to maximize their effectiveness, these foams must be properly applied as gently as possible to the surface of the fuel. Responders must avoid plunging the stream of foam directly into the fuel. This will merely agitate the fuel, dissolve the foam, and ultimately fail to create a blanket. Instead, direct the foam stream to a vertical object, in or behind the spill area, such as the far tank wall, and allow it to run down onto the fuel. When no obstacles exist to gently bounce the foam, firefighters should attempt to roll the foam onto the fire by hitting the ground in front of the spill. With some nozzles, it may be possible to elevate the foam and let it gently rain down directly on the spill. In cases where it's not possible to gently apply the foam, the best option may be to protect surrounding exposures, first responders need to be well trained in application techniques. It's important to note that alcohol or ethanol-type fuel fires require a higher application rate to extinguish the fire than gasoline. According to NFPA Standard 11, responders should contact specific foam manufacturers on what application rate they recommend for specific polar solvent fuels with their brands of foam. It's critical that all responders wear appropriate NFPA-compliant personal protective equipment when fighting ethanol fuel-blended fires. Protective clothing is designed to protect the wearer from head to toe and is proven to reduce the severity of injuries as well as save the lives of many firefighters. The following components, as long as they are NFPA compliant, are considered the minimum required PPE. A helmet with either a face shield or eye protection that meets American National Standards Institute (ANSI) standard, a protective hood, a turnout coat, turnout pants, gloves, boots, and proper respiratory protection. All emergency responders across the country have the potential for responding to transportation incidents that have ethanol and ethanol-blended fuels at different percentages, E10, E85, and fuel-grade ethanol. While bulk facilities may store pure gasoline, almost all gasoline tank trucks will be carrying ethanol blends. Unless responders are certain they are dealing with pure gasoline, they should treat all 1203 placards as always containing ethanol, and always use AR foam for over-the-road incidents, since AR foams are effective on both alcohol and hydrocarbon fires. Fire departments should develop means of having a supply of AR foam readily available. Each fire department needs to know what products the facilities in their area have on hand and what specific hazards are present in their response area. For all incidents, if responders are uncertain whether a fire is a hydrocarbon, alcohol, or ethanol blended product, AR foam is the foam of choice. As with all emergency responses, risk assessment is critical. Choosing the right foam concentrate, alcohol resistant, is part of the risk assessment when dealing with transportation-based incidents, regardless of the percentage of ethanol involved.
Pre-incident planning is a vital factor in the strategy of controlling an emergency situation. Departments that have tank farms and fuel storage facilities in their jurisdiction should establish extensive pre-incident plans and schedule drills and a walkthrough on a regular basis. Success in an emergency response in most cases is determined by the amount of advanced preparation made by firefighters together with facility personnel. Incidents involving these facilities can be extremely dangerous and require advanced technical knowledge of flammable liquids, firefighting, and fire protection. It is imperative that departments establish relationships with the facility operators and staff and cooperate in developing emergency response plans together. Pre-incident plans with predetermined flow rates based on tank sizes and contents should be reviewed regularly. In many cases, a major fire incident at a facility will require special equipment and go beyond the capabilities of one department. Mutual aid and assisting companies should also be included in planning and drills. The purpose of pre-incident planning is to enable attack preparations and firefighting operations to be carried out at the scene of an emergency as efficiently and effectively as possible. Pertinent information should be collected about each site, including construction features, access, control systems, exposures, fire protection systems, utility disconnects, fire hydrant locations, water supply, especially if hydrants are not available, spill containment, tank information such as type of tank, diameter, application rate for the fuel normally in the tank, and the amount of foam concentrate needed. Finally, any other specific plant considerations that would affect response operations if an emergency should occur. The operation can begin more quickly if details about the incident site are known prior to the arrival of the firefighters, and if positions of equipment and possible hose layouts have been predetermined. An operable pre-incident plan must be put into a format that can be used at the incident site and distributed to all parties that may be needed to solve the problem. It is important to understand that sometimes all you can safely do is contain the incident and let the fire run its course. Knowing when to let this happen is an important component of safety.
For any incident, from storage facility fires to cargo tank or tank car accidents, you'll be better positioned to respond if you've done your homework. Make sure you understand the different threats that ethanol-based fires pose over gasoline or other hydrocarbon fires. Research your jurisdiction and find out where ethanol-blended fuels are being used and transported. Make sure your department has the right foam and equipment you'll need to mitigate an incident. Have an incident plan in place, and be in the habit of maintaining good relationships with the agencies that can offer support in a time of crisis. Your knowledge and planning are the best defenses against disaster.